In this video, we're going to solve a couple of rational equations. We're also going to check for extraneous solutions. So in this first equation, the first thing that we have to do is take care of this subtraction here. And to be able to subtract these two rational expressions, we need to find our common denominator. And to help with that, we're going to factor our denominators here. So you can see x can't do anything to that, but you can factor this 5x squared plus 6x. So I'm going to go ahead and do that. So the part that was factored out was just this x, and we did it twice because our denominator over here was the same as this one right here. So if we look at 5x squared plus 6x, there's a common variable there, and that's going to be the x. We factored it out. And it's the same thing as taking 5x squared plus 6x and dividing both of these parts by an x. So that part that we divide out is the x, and then we're left with 5x plus just a 6 because these x's go away, and then 2 minus this invisible 1 here is just a 1. So that's what we're left over with in both the denominators. And now I want to figure out what the common denominator is going to look like. And what we can do is multiply this part right here by a 5x plus 6, because now it looks exactly like this denominator right here. Now if I multiply the bottom part, I also have to multiply the top part. So squeeze in another 5x plus 6 up here. So 5x plus 6 over 5x plus 6 is just 1. So we're not multiplying the 1 over x by any different value. It's not going to change the value at all. It just changes the way it looks. So now we've got this common denominator, and it's all good. So next I'm just going to rewrite this left side of the equal sign. And now I'm actually going to take 5x plus 6 and multiply it by 1. So I'm going to get a 5x plus 6 up here in the top part. And then we're subtracting this 1. So I'm actually carrying out the subtraction now, because I have my common denominator of an x times the quantity of 5x plus 6. Now at this point I could clear some things up by combining like terms here. So I'm going to rewrite this left side again. And the terms I'm going to combine are the 6 and then minus 1. We're going to be left with a 5x plus 5 in the top part, and then I'm going to rewrite this bottom part again. Alright, there we go. So now I want to get rid of the denominators, these bottom parts. So to do that, I need this exact same thing on top. So I'm going to multiply the top part by an x to cancel out this x. So those go away. And I also have to multiply it by 5x plus 6 because this is going to cancel out this down here. Now to keep the equation balanced, I need to multiply the left side by the exact same thing. So multiply by 5x plus 6 and also an x. And it's nice because we have the exact same denominator on the left side of the equation. So this x crosses out with this x, and 5x plus 6 cancels out with this one. So now we're just left with an x minus 6 in the top part on the left side of the equal sign, and then a 5x plus 5 on the right side of the equal sign. Now at this point it looks a little bit easier. We want to get our x's by themselves, so I'm going to add 6 to this left side to cancel out that minus 6. I add it to the right side as well. And now let me rewrite the leftover up here so I have some more room. It's going to be an x equaling 5x plus, now this is 11 because I did 5 plus 6. And again, I want to get my x's by themselves, so I want to subtract out this 5x, so take away 5x from this left side as well, and I have a negative 4x equaling 11. And then to undo the multiplication of negative 4, I divide it, so that goes away. Do the same thing to the right side, and I'm left with an x equaling a negative 11 over 4. So at this point we want to check to see if it's going to be an extraneous solution, and it's not, because if I plug in a negative 11 over 4 here for this x, I'm not going to get a 0, and chances are if I go ahead and plug in a negative 11 over 4 right here for this x and this x, I'm not going to get a 0 in the denominator either. So this is going to be my final answer, which is not an extraneous solution. an example of an extraneous solution would be maybe if you had, let's see, a 3 over x minus 2, say on one side of the equal sign, and you solved an equation for x equaling maybe 2, right? So if you plug in this 2 for this x, 2 minus 2 is going to be 0. So then you'd have 3 over 0, which just can't happen. You can't divide by 0, so that would be an extraneous solution. You solve for x, which equaled 2, but when you plug it back in, it just doesn't work. Okay, now on to the second problem, and the first thing that we have to take care of in the second problem is this subtraction part here. So I'm going to rewrite this and write the 1 as a fraction. So there we go. And to be able to subtract this 1 from the rational expression here, we need to have a common denominator. So I'm going to take the denominator and multiply it by an x plus 6, and that means we have to multiply the top part by an x plus 6 as well. So now I have common denominators, and I could actually carry out this subtraction. So we have an x plus 3, and then we're going to subtract this entire part right here. So we're going to be subtracting an x, and then we're also going to be subtracting that 6. So we kind of have to distribute this subtraction sign to both of these terms here. And then that's all going to be over an x plus 6, which equals this rational expression on the right side. Okay, now I'm going to my like terms here. So I have an x and then minus x. So this goes away with that. They cancel out. And then I have a 3 minus 6. So that's going to be a negative 3 on top. And then in the bottom we have an x plus 6. And this is going to be 1 over. And normally I would write my trinomial, but I know that my next step involves getting rid of this x plus 6 in the denominator, and chances are when I have a trinomial over here, I might be able to come up with a factor that is also x plus 6, which would help canceling things out. So I'm going to try to factor this and see if I could get a common factor of this one right here, x plus 6. So I need two numbers that multiply together to get a negative 6 and also add together to be a 5. And those two numbers are going to be a positive 6 and a negative 1. So we're going to write an x plus 6 and an x minus 1. And that works because 6 times negative 1 is negative 6. And then 6 plus a negative 1 is a positive 5. So these are going to be the factors of this trinomial. And now I can carry on to my next part, which involves getting rid of this x plus 6 in the bottom. So I multiply the left side in the numerator on the left side by an x plus 6. So x plus 6 over x plus 6 goes away. And I have to multiply this right side by that same binomial to keep everything balanced. But it's nice because these two go away, and we realize that because we factored this trinomial. Okay, we also want to get rid of this x minus 1, so I multiply the top part by the x minus 1 as well. So this crosses out with this, or this cancels out with that. And then the left side, though, has to be multiplied by that same binomial, again, to keep things balanced. So now I'm left with, I'm going to rewrite this up here, an x minus 1 times a negative 3. That's on the left side of my equal sign here, and that's going to be set equal to just this 1 because that's the only thing left over. So now I want to distribute this negative 3 with both of these terms. So negative 3 times x is going to be a minus 3x, or a negative 3x. And then a negative 3 times a minus 1 is going to be a positive 3, which all equals 1. And now I'm going to solve for x, so I take away 3 from this left side. I take away 3 from the right side as well. I'm left with a negative 3x equaling a negative 2. To undo this multiplication of negative 3, I want to divide it by a negative 3, so that goes away. And then divide the right side by a negative 3. So we're left with an x equaling a negative over a negative is just a positive, so I'm going to rewrite this as a positive 2 over 3. Think of those negatives as canceling out, and then I cannot reduce 2 over 3 at all, so that's going to be my final answer. We also want to check to see if it's extraneous or not, and if you plug in 2/3 back into any one of these x values, I'm not going to get a 0 in the denominator, so it's not going to be extraneous. So we could call this our final answer.